In today's note, we're going to continue along with solving equations, and we're going to look at multi-step equations. So just to go over some of the things that we looked at with solving equations in general, in our past note, we looked at single step or one step and then two-step equations. So those basic ideas still carry over, and those are that changes can be made to an equation as long as its balance is kept. And what that means is whatever you do to one side of the equal sign, you have to do to the other side. So if you're subtracting by a number on one side, you have to subtract by the same number on the other side. All right, so that's when we're saying what you do to one side, you have to do to the other, or you want to balance it. That's what it's referring to. To undo something or to cancel something out or to get rid of something, you have to do the opposite operation. Right? So we have basically our pairs, right? We have addition and subtraction, and we have multiplication and division, right? So if you're given one, you do the other. You're given the other one, you do the reverse, right? So if you're given addition, you have to do subtraction. You're given subtraction, you do addition. Multiplication, you cancel out by dividing. If you're dividing, you cancel out by multiplying. Right, so those are basically your pairs that you're looking at. To complete the steps, or where the steps you should be completing them in, is the reverse bedmass. Right, so you look for that subtraction or addition first, and to the variable. Then you deal with your multiplication or division, then exponents, brackets we're going to talk about in a future lesson. So just as an example, we're going to go through one way, and 7x minus 4 equals 10. So I can see the variable that I want to isolate, that's the x. To get it by itself, I can see that I'm going to have to deal with multiple steps. There's multiple things going on here. There's multiple numbers on the side of the variable. So to figure out where I start, I'm starting with subtraction or addition. I do see some subtraction here with minus 4. To cancel that out, I know I have to add 4, or the opposite of subtracting. To keep things balanced, I have to do the same thing to the other side. So now I'm left with 7x, because the plus 4 and the minus 4 have canceled out, equals 14. Now I'm down to a one-step equation, so to get the x by itself, because there's multiplication going on here, right? Remember when we see the number and the letter and no sign or operation in between, we assume it's multiplying. So to cancel out multiplying, I'm going to divide. To keep things balanced, I'm going to divide on the other side. And now it'll leave me with, again, the 7s on the one side will cancel out, and I'm left with x equals 2, which is my final answer. So that's one way you can write it. If you're comfortable with the steps and how to cancel things out, you can simplify your work. Right, so on the other side, it's the same example. So I know that to get rid of the minus 4, I have to add 4, so I'm going to cancel that out. So I'm going to go right to the 7x. I know that's going to be gone. Because I know that I've added 4, I can just do the 10 plus 4 on the other side. So I know that 7x is going to equal 14. Again, I know that in order to cancel out multiplying by 7, I divide. It will cancel out on the one side. So I know in the end I'll have 14 divided by 7, and then in the end it's equal to 2. So again, it's the same steps, you're just not writing down what you're doing to both sides. Right? So again, whichever way you choose to do it, both ways are fine. If you're not too comfortable with remembering what the steps are, or you're having trouble figuring out what you're doing, then I would stick to the side on the left, right? Show your work at each step. Show what you're doing to cancel things out. Show that you're doing them to both sides. But again, if you're comfortable with that, you're more than welcome to shorten it without writing both those steps out. So when we move into solving multi-step equations, a multi-step equation is when we have multiple variables or multiple variable terms. So if I look at the first example, I can see multiple variable terms with 3x and 4x. So the tip, or the thing that we have to do, and we can see it here, is we have to collect like terms on the same side of the equation. So in order to solve a multi-step equation, we need to collect our like terms and make sure we only have one variable term. So if I look at example A right now, I have two variable terms that I've underlined here. Because they're like terms with the same variable, I can collect them. So this goes back to a previous lesson. So 3x plus 4x is 7x. I can simplify the other side. 15 plus 6 is 21. And now I've taken it from a multi-step down to a single-step equation. To get rid of the multiplying by 7, I'm going to divide by 7. I'm going to balance it by doing it on both sides. It'll cancel out on the one side. And I have x equals 3. So that is my final answer. In example B, again, I can see I have multiple variable terms, 3x and the 2x. So if I want to simplify this, I'm going to collect my like terms. So I can add those two underlined terms together to get 5x. The plus 4 is still there because I can't combine that with the 5x. They're not like terms. And the minus 16 is still there. Now I'm down to a two-step equation. Right? I need to get rid of the plus 4 by subtracting 4. I'm going to do that from both sides. So I have 5x, because this will cancel out, equals negative 20. To get rid of the 5, or the multiply by 5, I'm going to divide both sides by 5. It'll cancel out on one side, and I'm left with x equals negative 4 as my answer. Example C. So example C is a little bit different because I can see that I have multiple variable terms. However, one of them is on the other side of the equal sign. And we can see this note over here that I'll kind of put in black to highlight it. To collect like terms, they need to be on the same side of the equation. So I can see that I can collect some terms already. I can do the 5x minus 8x and get negative 3x equals x plus 8, but I still have this x on the other side. So how do I move it to the other side, or how do I get rid of it on the one side? And the answer is the same way we've been moving things or canceling things out. Do the opposite. So because I have 1x on this side, to cancel that out, I'm going to minus x. Right? Same thing, opposite operation. To keep things balanced, I'm going to minus x from the other side as well. One side cancels out. I have minus 3x and then minus x, so I'm at minus 4x now, equals 8. All my x's are on one side. I only have one variable term, or only one variable. I need to get it by itself, so I'm going to divide by 4, negative 4, sorry, divide by negative 4 on the other side. It'll cancel out on the one side. X is equal to negative 2, or 8 divided by negative 4. If we want to check our answer, again, remember to check our answer, we just sub our answer that we found back into the original equation. So everywhere I see an x, I'm going to replace it with negative 2. So 5 times negative 2 minus 8 times negative 2 equals negative 2 plus 8. And I'm going to check if I kind of make a table out of this. Let me move it down a bit, it's getting a little cramped. I'm going to check, does my left side equal my right side? So I get negative 10 minus negative 16 equals, or on the other side it's 6. So negative 10 minus negative 6, or basically negative 10, I can change that to plus 16. So I get 6 equals 6. My left side does equal my right side, so my solution that I found is good. If you got the left side different from the right side, I would suggest going back and checking your answer or checking your steps, because you probably made a calculation error somewhere or you did the wrong steps. So let's just continue through into some more examples. D, y minus 7 equals 6y plus 3. So again, my variables are on the opposite sides. I have multiple variable terms or multiple variables. I need to get them together by getting them onto the same side. So I like having my variable on the right side or on the left side, so I'm going to move or need to move the 6y over or cancel it out from this side. In order to do that, I'm going to do the opposite. I'm going to keep things balanced by doing it to the other side as well. It'll cancel out on one side, y minus 6y, or 1 minus 6 is negative 5y, minus 7 equals 3. Here now, I am down to a two-step equation. I'm starting with the subtracting first. So in order to cancel out minus 7, I add 7 to both sides. Negative 5y equals 10. Because those cancel out. To get rid of the negative 5, I'm going to divide by negative 5. I'm going to do it to both sides. It'll cancel out on one side. And then y equals negative 2. And that's my final answer. E again looks complicated, but I'm going to start with finding my like terms to try to simplify some things. Right? And I have actually multiple, so I'm going to use straight lines for these y's, and I'm going to use squiggly lines for the other ones. So if I look at this, I can, on the one side, actually those aren't great squiggly lines, so let's just use a different color. So I have my 4y and minus 5y. I want to combine those terms, so I'm going to do 4y minus 5y. Remember to look at the sign in front, right? So it's minus 5y. So 4 minus 5y is negative 1y. I still have the plus 6 equals, and on the other side, I can combine the negative 3 and the 8 because they're like terms. So I get 5. Next, what I want to do is I have multiple steps here, so I want to get rid of the addition or subtraction first. So to get rid of the plus 6, I need to minus 6. I'm going to minus 6 from the other side. It'll cancel out on one side, so I'm left with negative 1y equals negative 1. Now you may think that you have y by itself, but that negative 1 there in front of it is something we don't want. We want just y on its own. So in order to get rid of the negative 1, I need to divide by negative 1. It'll cancel out on the one side, and I'm left with y equals 1. So that means my answer for E is y equals 1. In our extend question, how can you use equations to model and solve problems? So in my example here, I have two triangles that have the same perimeter. Remember, perimeter means distance around an object. Right, so it's the entire distance around the objects. So how can I come up with an equation or a model or something to model this problem? Well, I can figure out the perimeter of each by adding up all the sides. So the perimeter of 1 and the perimeter of 2, I should be able to solve because it's just side 1 plus side 2 plus side 3. And the same goes for the other triangle. Side 1 plus side 2 plus side 3. So 2x plus 3 plus 3x. I'm going to look for my like terms, which in this case are the 3x and the 2x, so I can collect those like terms to make it 5x plus 3 is going to equal the perimeter of my first triangle. My second triangle, same idea. I'm going to add up my sides. So side 1 is x plus 3. Because it's addition, I don't need to put brackets around it. And then plus x plus 4. So here I have a few more like terms, but if I go through and find them, I have my x's, and I also have just my constants. So when I collect those, x plus x plus x is 3x, 3 plus 4 is 7. Now I need to solve for x. The other piece of information that this question gives us is that the perimeters are the same. So that means that 5x plus 3 is going to equal 3x plus 7. And this right here, this equation, is something that I can solve because I know how to solve equations when I have multiple variable terms, right? Or I know how to solve equations in general. So again, I figured out my two separate equations. Let me just center this. I've set them equal to each other because in the question it says they have the same perimeter. So the answers in the end, their overall perimeter will be the same. So that's why I set them equal to each other. And now I just need to solve. So I want to get my variables together on one side. In this case, I'm going to minus the 3x from the one side. I'm going to do it to the other. They'll cancel out on one side. I'm left with 2x plus 3 equals 7. Now I'm down to a two-step equation. To get rid of the plus 3, I'm going to minus 3. I'm going to do the same thing from the other side. One side cancels out. 2x equals 4. Now I'm down to a single step or a one-step equation. I'm going to divide by 2 to get rid of the multiply by 2. Do it to the other side to keep things balanced. They cancel out on one side. And I'm left with x equals 2. So that is my value. So I know that x equals 2. If I wanted to, I could go back into the equation and actually solve for what does each perimeter, or what does the perimeter work out to be. Right? But using my understanding of how to add or combine like terms, combined with my knowledge of solving equations, I can solve this problem to figure out what is my value of x.